Hey, good afternoon, everybody. Welcome to Integrated and Automated, Securing Every Stage of Cloud Adoption. I'm John Morello. I'm the Vice President of Product for the Prisma Cloud compute parts of a product that we ship at Palo Alto Networks. I was formerly the Chief Technology Officer at Twistlock, so if you guys are familiar with the Twistlock product that kind of pioneered the container security space, that's where I come from.
Mukesh Gupta, VP Product for our software firewalls portfolio at Palo Alto Networks. That is VM series, the virtualized version of our next-gen firewall, and CN series, which we launched last year, which is the containerized version of our software firewalls.
So this session is really designed to give you guys a kind of a, I would say a high level, but a very broad and comprehensive overview of a lot of the technologies and capabilities that people think about when they think about how do I secure the cloud. I've got all these great services that are available in AWS. I still have, in many cases, really significant regulatory or compliance requirements that I need to meet. What are the tools and what are the practices that I need to use, and really what are the threats and countermeasures that I need to be able to understand and to take to be able to protect my environments across all the various AWS regions and services that I run within those regions. So that's really the focus of what we're going to talk about. So we're going to kind of go through a lot of different technology areas and talk about different things that you need to consider and keep in mind when you think about cloud security. And then at the end, we're going to leave a lot of time for question and answers, because I think it's always great for you guys to be able to hear what others have questions about and for us to be able to give you perspectives on things that are top of mind for you. So, a lot of ways that the place to start when you think about securing anything is you can't secure something that you don't know, right? You have to really understand what you have within your environment to really know how do you secure that environment and what the risks are that are posed to that. And historically, a lot of that knowledge about what you have and what do you need to secure really came purely from an inside perspective. In other words, you might have been using a tool like Qualys or Tenable or something else that you were using, maybe even just like Nmap for an example, where you were trying to assess the inside of your environment, an inward-based perspective to that. And that's still really important, right? It doesn't go away. You don't, no longer need to have that kind of visibility about what's on the inside of your environment and how do you understand the risks that are associated with that. But one of the things that we see customers really having a real important need for around cloud security in particular is also to supplement that with an outside-in view. And specifically what we're referring to is the ability to have that understanding about what resources you have across your environment, how they're configured, what vulnerabilities exist, like what ports are listening and so forth, but to have that from the same perspective that an attacker would. If I'm coming from the outside, from the public internet, what are the aspects of your environment that I can see? What is the relative risk profile of that? And thus to be able to develop a really more complex and more sophisticated kind of two-dimensional view of that environment, not just what you have internally, but also what are those assets that are exposed from the outside. And you can see a lot of the major categories that fall into this broad area that's typically referred to in the industry as attack surface management. And it's a lot of things you might think about. Do I have remote access services enabled? Do I have like some kind of crypto miner that might be listening in my environment for commands? Do I have IoT devices that are out there that are listening and connected to my network, but I don't realize may have be offering up a remote shell? And one that you see on here that I think is particularly important in cloud, because we see people deal with this a lot, is number 9, which is exposed development infrastructure. One of the things, attack surface management is not a unique to cloud problem space. I mean, this is something that's just applicable or just as applicable for your existing kind of self-managed on-premises environments, but it's not particular to cloud. But I think it's particularly important for cloud because of how easy it is for your users, your developers, your system admins, the people that are working in a cloud environment, to be able to provision infrastructure and connect that infrastructure and those resources that are running inside of it to the public internet with almost no friction, without any boundaries. And if you compare and contrast that to the way that might have happened in your traditional data center, 10 years ago, if I had a web service that I wanted to make available to the internet, and I'm a developer, I have to build that. I probably put in some kind of change ticket, and somebody who runs firewalls goes in there and understands that, and they create a firewall rule, and they ask me a bunch of questions about it, and so forth. There's a lot more rigor to the process and just a lot more sort of friction involved with being able to make that publicly facing service available. Whereas today, if you're running on AWS or really any cloud provider, if I'm a developer, I can make something publicly available with virtually no effort at all, right? You can configure accounts to make that more difficult or get alerts to that, but fundamentally, it's a much easier process for me to do that. And I'm not even talking about it from a malicious standpoint. It's not necessarily people that are trying to provide some kind of remote implant for people to get access to, but just a developer who creates a system, they test something, and then they just forget about it. They move on to the next problem, the next ticket, and they don't remember that suddenly they've left out there a web service that's vulnerable and it's connected to the rest of the development environment, which is also connected to the UAT environment, which is then connected to the production environment somehow, right? And what the attack surface management capabilities and kind of family of technologies allow you to do is to understand not just what you have in your own environment, but how those things are exposed to the outside world. So you guys might have heard of a company called Expanse that was purchased by Palo Alto Networks about a year ago. That was really a pioneer in that space. And we've integrated Expanse with the rest of our Cortex product line to really be able to bring all of that information about what's publicly available, what's the configuration, the risk profile of those things, to bring that into that Cortex data lake so that you can have a really comprehensive view of the risks that you're exposed to from that outside-in view, but also combined with the inside-out view and all the other data that we can provide to that Cortex data lake from our VM series firewalls and our physical firewalls, from our Prisma Cloud product. So you have a really consolidated way to really understand completely what your risk profile looks like and what that attack surface looks like to outsiders that might be coming to you from that public internet. So that's one step. The next step that we usually talk about when we think about securing the cloud is about the applications that you're running on the cloud. Not, when you're buying cloud services from AWS, you're trusting that Amazon is going to run those cloud services securely, that you are purchasing an EC2 service or you're consuming an EC2 service that meets the various regulatory and compliance regimes that Amazon attests to, right? You're not configuring the back end of EC2 or S3 or any other service to make sure that it's secure. You're consuming the service that's been provided to you. But on top of that, you're running your own software, right? Inside of that EC2 instance that Amazon provides, you're running your own operating system, or at least one that you've chosen. You're running your own application stack, maybe something you've completely authored yourself or that's got some open source components that you've added to. But in any case, there's a whole set of software and potential risks thus that exists inside of that layer that's on top of what the cloud provider is offering to you. And that's become a particularly important challenge as people adopt more cloud-native applications, where those cloud-native applications are a bit different than the way that people had historically run infrastructure. Again, if you wind the clock back, not even necessarily 10 years, maybe just 5 years or so ago, people were not still at that point really actively utilizing, at least in a widespread way, a lot of these newer, more modern ways of developing and deploying applications like containers and serverless functions that really provide a lot greater control and thus a lot greater security responsibilities to developers. You can see here some of the things that's cloud native, presents as challenges. New architectures are part of the challenge because there's just different form factors that you have to be able to protect, and you may need new tools that take advantage of that. But really, I think the most important threat or most important challenge that you're faced with is the middle one there, which is the reason why most organizations are adopting containers and cloud-native technologies like serverless functions is because they want to increase the agility of their own software, the software that they build to serve their constituents or to have a competitive advantage or to make it easier to sell stuff to their customers. They want to be able to do that more quickly, and they want to have less friction in the process, right? And so they're using these tools of kind of mass innovation like containers and serverless and so forth to do so. But as part of that transition, they're also now empowering the developers to have a much more direct way to say, hey, I built this software today. I don't have to hand it off to somebody else and give them a run book and hope that 3 weeks later it's deployed in production. I can literally just run the same job for my CI or CD tooling, and that thing that I just built can be running live in production right away, right? And that's a great thing in a lot of cases. It enables you to have the kind of innovation and fast iteration of software that's really desirable. but that also has some real serious security implications, right? Because if you don't have the right tools and processes in place, it also makes it really easy for a developer to potentially introduce vulnerabilities or insecurities into the environment. Again, they may not be acting maliciously, but if there's not a control in place where there's somebody who's actually reviewing that, as they may have had to in the old world, now as a developer, I might download some cool open source product that I want to build the rest of my application around, but I don't realize that's got serious vulnerabilities. I go and I deploy that in production, and even if your network perimeter is great, even if you've got all the attack surface management we just talked about, suddenly you may have introduced unknowingly a really critical vulnerability to the environment. So part of what cloud native really presents as a challenge is that fact that you now have a lot more things that the developers are in control of. Those things are also changing a lot more rapidly. Historically, security tools kind of be built around this premise that, an application, a virtual machine that somebody had deployed was probably not going to be changing every day. It probably was going to be something that you deployed and it sat out there for weeks, months, years, potentially even. And so the whole way that product, that security platform could be built may have assumptions about the longevity and kind of durability of the resources that it's protecting. And a lot of that was shown you in the ways that it required manual activities for you to configure it. It's one thing to say that I want to have a tool that requires a manual human operator go in there and create a security policy to protect a VM if I know that VM's probably going to be doing the same thing for a long time going forward. It's a much more onerous and difficult thing if that VM is decomposed into a bunch of microservices that run in containers, and those containers are constantly running new images as the developers are iterating on those microservices. I can't now expect you to create, a dozen different protection profiles for each one of those microservices and keep them up to date as the application is changing all the time. And so one of the other challenges that you have here is this constant state of change that gets created can oftentimes leave security teams behind. If you don't have the right tooling from a security standpoint, your developers and the business that's depending on those developers to create applications that give that competitive advantage and serve their users, that business is not going to be satisfied with the security team saying, hey, slow down, all these great things that you guys want to deploy that are going to sell software or sell your product, whatever that may be, you can't use those because we haven't had the time to go back and manually, examine and approve all those things. People just don't flat out accept that any longer, and it's important that you have security tools that can, again, move with the velocity of those development pipelines. One of the other challenges that developers are often faced with is that there are many different layers to that stack. You're not really looking at just like a VM that you deploy into one environment, and again, it's like, kind of this standalone managed thing that somebody SSHs into and, configures on a periodic basis. You've got a multi-layered environment when you think about the cloud. Again, as I mentioned earlier, you're consuming services from Amazon. Amazon, on top of those services, you're kind of deploying your own infrastructure, right? You're composing your own infrastructure from, VPCs and EC2 and S3 and EBS and so forth. So all of those things, compose what your virtual environment looks like. How are you configuring that? Are you configuring those things securely? For example, do you have that EC2 instance in a security group that provides the right kind of ingress traffic filtering to it? Those are the kinds of things that kind of are generally referred to as posture management. How can I go to my cloud, across my various cloud providers and cloud accounts, and make sure that the services that I'm consuming from that cloud provider are configured properly? And then on top of that is all the different workloads that I might be running there. So as I have that infrastructure, I've got a Kubernetes cluster that I deploy on top of EKS. I might make sure now through that posture management layer that it's configured correctly. But what about the software that I run in that? What about the virtual machines that are running that software within the cluster? What about the containers that are running the images that you deploy your application in? So not only do you have multiple layers of the stack, in a way that's probably much more distinct than what you had in the traditional world, but now you have a lot more form factors that you have to think about as well. And for us within Twistlock and what's now become Prisma Cloud, we've really tried to make sure that you don't have to have additional tools just to be able to protect all these different form factors that your developers probably are going to already be using today. It's not about everybody moving from virtual machines to eventually getting to serverless. There are pros and cons and advantages that you see through each one of these different form factors. Serverless functions give you great agility and the ability to not really have to care about the infrastructure at all, but you don't typically have a lot of backwards compatibility or control over the environment. Whereas virtual machines, conversely, give you great backwards compatibility and control, but there's a lot more stuff for you to manage. And for each one of the workloads that exist in your environment, your users are probably going to be choosing the right one of these form factors for any one of those given workloads that they have. So what we see not as just the future state, but as the actual present state today, is that it's not that people are going from one side of this to the other, but that they're using all of these things simultaneously. And it's really important that you don't have a security tool, or fragmented security tools, I guess, that require you to have a different approach for securing VMs versus container as a service platforms versus serverless. You know, as you guys all, see in your day-to-day jobs, if you've got half a dozen different tools just because you have to have a different one for each form factor, being able to integrate that and really have intelligence based on that and understand what do I do with the data that it provides me becomes really burdensome, right? So what we've tried to do is to basically build a platform in Prisma Cloud that gives you the ability to protect across all these different form factors. So through one unified agent capability that we've built, it's packaged differently, of course, for each one of the different form factors, but from one single agent, you can protect a virtual machine, a serverless function, a container, a Kubernetes cluster. All the data, all the policy lives in one place, so it's a lot easier for you to be able to scale out your security across all these different form factors and all the various places where you may run it. Form factors are really one of the things that shifts kind of the production side of your cloud environment, but an equally important opportunity and challenge for that matter as well, as we talked about earlier, is how do I secure my environment throughout its life cycle? So we talked about just the physical dimension a moment ago, all the different form factors you have. Think about this as the temporal dimension. How do I secure my application as it evolves over time? One of the opportunities that Cloud Native gives you, because there is a much more rigorous kind of thought and molding of the technology around the notion of a life cycle and a pipeline, is you have the opportunity to inject security a lot earlier to the development life cycle than you had historically. Historically, most organizations, as they built applications, would really start thinking about security typically after the application was built. Some people may be using SAST or DAST type technologies to be able to do some testing earlier, but those were typically really error prone and didn't have really very good uptake. And even if they were used, they typically required a lot of manual overhead and manual remediation for the results. What Cloud Native really gives you, because you have the same image that you build in one environment, that you push to a registry for staging, that you deploy into production, and that you run as a durable entity in production, you really have the ability now for the first time to viably be able to apply the same security policies that you have in production all the way back to the beginning of the life cycle of the application. So for example, you might say, in my production environment, I don't want to run anything in my PCI environment that has a critical vulnerability that's more than 30 days old. Great, so you can enforce that at deployment time in production, but you can, through the same platform, also enforce that at build time. So that as your developers are building their software in whatever tool they're using, be that CodeFresh or Circle CI or whatever they might be using to do their software development, they can integrate that check into that same tool that they already have on hand, and to have that business logic to be able to really clearly express the same kind of policy that they have in production, so that the things that are coming from development, you can already know meet your requirements, your baseline, what you've determined to be acceptable from a vulnerability and secure configuration capability. And that's a really different opportunity that Cloud Native gives you. Of course, it's not just a matter of saying I use containers and so naturally my software development lifecycle is more secure. But as you use containers and Cloud Native technologies like serverless, you have now really, for the first time, I would say, a really viable opportunity to do that broadly across your environment, across all your different pipelines, and to do so in a way that your development community will accept because it's very natively integrated into the tooling and the processes that they're already using today. We've done a lot of work with AWS over the years. The last thing I'll talk about before I pass it to Mukesh is just to highlight the depth and length of the relationship that we've had. If you go back, really all of the launches that AWS has had around technologies that are relevant in the cloud native space, we've been a launch partner of. I remember really clearly back when we were starting Twistlock in 2015, when Amazon started to launch ECR, and it was right before the Christmas holidays, and actually we found out about it when I was on a duck hunt, and I did the work to get us ready to be a partner for ECR from a duck camp. I had to drive up a hill to be able to send an email about it. But we've really been there for all the other launches that they've had. So the reason I bring this up is you can feel really confident that as you guys utilize a lot of these technologies that already exist on Amazon and the new ones that Amazon is always releasing, right? That's one of the great things about AWS is there's always new services, there's always new things that are being solved, problems that are being taken care of as these new services launch. You can trust that we're going to be there with you, that we're going to help you adopt those new technologies securely, and that we're going to integrate with them in a really meaningful way so that you can have a great experience using both Palo Alto Networks technologies and AWS technologies at the same time. So like I said, we'll have some time at the end to talk through my section as well, but for now, let me pass it to Mukesh to talk about the networking piece.
Thank you, John. All right, so the next piece of protecting your cloud is to secure the network communication. So all your applications that you're building, running in cloud, are connecting outbound to the internet to download code, update code, use external APIs from Google, Facebook, and whatever. That communication is, pipe can also be used for connecting to command and control centers. So network is a big attack factor. As you build microservices, there's a lot of connectivity between applications as well. And you need to make sure that someone breaks into one application, they can go sideways and start breaking into other critical applications. So there's this east-west, and then all your applications are serving some customer, some user, internal or external. So there's that inbound aspect. So you need to really make sure you keep your network protected on AWS. So what I wanted to do is just kind of walk down the memory lane. I don't know how many people have been around. I've been dealing with network security for 25 years. How network security has evolved, over time, because I think it'll help you understand the power of Palo Alto Network Security Platform. So if you just go back, like network security was a firewall. And the world was kind of simple at that time. We had headquarters and branch offices where employees worked, and then you had internet and data centers where internet was available for websites and data center hosted your private applications. And firewall was a simple device that kept the good people in and bad people out. It was that simple, just allow, deny. But then, of course, attackers got smarter. Whatever was allowed, they used that to get in and break in. They used, phishing type websites or bad websites to download stuff into your environment. So firewall wasn't just enough for these advanced attacks. And network security industry has the tendency to throw another solution, to every new problem. So that's what we did. We invented IDS, IPS box that would allow you to detect intrusions and prevent them. URL filtering, secure gateways, sandboxing technology. So before you knew it, you had like seven boxes sitting at your perimeter that made it complex, to operationalize it, and also brought your security efficacy down because you need to now make sure that you're programming all these boxes correctly. And then what happened was, people started moving out of the offices, working on their mobile phones and laptops from their homes. SaaS applications moved your private applications, outside your data centers. Salesforce, Workday came along, and then 10, 15 years ago, AWS started moving your data center applications to public cloud. So all this, stuff became pretty complicated. Security industry responded with coming up with, specific solutions for public cloud, network security related. So software stack for branch and mobile users. People invented, Swig offered as services. But again, now it has become complicated. Most of our customers are running like 40, 50 different security technologies. And as you invest into these different solutions, life becomes complicated and security goes down. And that's the problem we're dealing with. At the same time, if you look at the attackers, they're getting more and more sophisticated, using AI, automation, machine learning to just get through whatever protections you have. Right now, if you look at how the attack surface is evolving, we see hundreds of thousands of malware variants, new malware variants coming up almost every year, and it's increasing exponentially if you look at the graphs. The other problem is all they need is one little hole, one way to break into your infrastructure. There's very little east-west protection, so once they are in, they can go sideways. We've seen instances where within 45 minutes, they can go within 30 minutes, some malware has infected 45,000 instances, within 30 minutes of the first breach. So it's pretty serious. And if you look at the impact of these breaches, you can pretty much hear them in news every day. SolarWinds and Colonial Pipeline. It's not just money. It's starting to impact like U.S. economy. When pipeline went down, gas prices started going up. And 2 months ago, I read an article where a baby in Alabama died because the hospital couldn't take care of the baby. They were busy dealing with a ransomware attack. So now we're dealing with a ransomware attack. We're losing human lives. So that's how the situation is at this point. So what we are trying to do is Palo Alto took a very different approach to this 16 years ago. When we started the company, we said we don't need these 6-7 boxes. What you need is one platform. And that's how we invented Next-Gen Firewall. For all these different security, functionality, we came up with cloud services. So threat prevention was for IDS, URL filtering was for URL filtering. And once you deploy one Next-Gen Firewall, it would just you can just enable these services, and these services were cloud services, which was pretty nifty 16 years ago. And we invented App ID, so you didn't have to deal with ports and protocols. We invented user IDs, so you didn't have to deal with IP addresses. You can actually identify people with their usernames and security groups. So that's how the company started, and that's what made Palo Alto the leader in this network security industry. And as we came along, we took the same security technology, and we turned that into our software firewall. So I'll talk about VM series and CN series, but it really came from the same technology. And then for mobile users and remote branches, we also have firewall as a service, the SASE stack called Prisma Access. The good news is that all these form factors, the hardware, software, and SASE, are all powered by PAN-OS. So the same App ID, same user ID, same PAN-OS engine works on all three. So anytime we make it better, it makes all three better. And they're all powered by the security subscriptions, so TP, Wildfire, and those were the subscriptions we started the company with. And as we go along, as we see new security use cases, we don't build a new solution to it, we just add a new security service. So we've added DLP for data loss prevention, we have added DNS for handling DNS security, CASB, IoT. So as we come up with new services, we just add those services. Those services are also backed up by our Unit 42 team. So we have 200 plus threat researchers that are constantly looking at all these cyber attacks and analyzing them, looking at all the vulnerabilities that are coming up, and feeding these cloud services that are already using AI, ML to learn and evolve. So that's what so the threat researchers are feeding that human intelligence, and all of that intelligence goes into our platforms. So what comes out is, at this point, we have 85,000 customers, hundreds of thousands of these firewalls deployed. We are processing 15 trillion transactions on our firewalls every single day. And that results in, not only we are protecting our customers with it, we are also learning from it. All this learning goes into our cloud-delivered security services, where we use AI and ML technology to learn from it. The human intelligence from Unit 42 also comes into those services. We release about 4.3 million security updates every single day to our firewalls. That results in 227 billion threats that we block across the world. So what happens is you see anything going wrong across any of our firewalls, like SolarWinds, we detected that, and then we feed our services and we push that intelligence down within minutes to all of our firewalls, and now all of our customers are protected by a new thing that was just discovered. So that's kind of the power of this platform. Now I'll switch to the VM series and CN series, but I wanted to tell you all of that because the real power of VM series and CN series is because it's powered by all of that platform technology. So what VM series is our virtualized version. It's been in AWS for about 7-8 years now, and it's available as BYOL as well as Pego. Big business for us. Lots and lots of customers using it. But beyond it, it's powered by PAN-OS and all the security services that I just talked about, Unit 42 threat intelligence. So it's getting smarter. The security part of it is pretty good and keeps getting better and better. So what we really focus on is three things. One is we keep getting it integrated deeper and deeper into the AWS ecosystem, and that's what you see, GuardDuty, Security Hub, CloudWatch, CloudTrail, S3 buckets, bootstrapping from AWS metadata. So we've invested a lot in making it deeply integrated into AWS ecosystem. The second thing we focus on is making the networking in AWS better for firewalls. So VPC peering, VPC traffic mirroring, Transit Gateway, the Gateway Load Balancer, which was phenomenal last year, which makes it really, really simple to insert the firewalls in the path of traffic, because the firewalls are only useful if you can insert them in the right places. Only then they get the right visibility and right protection for you. So we've been working with AWS for a long time, and we're super excited about the Gateway Load Balancer. So most of our customers use all of this orchestration, integration to automate everything. Most of the cloud customers are not deploying these firewalls manually. They're not managing them manually. They're all just part of their blueprint, and they just get deployed. A lot of customers have to do this heavy lifting before they can deploy their first firewall. So we've also invested in Panorama, which is our management platform. So you can just click a few buttons there, and we just orchestrate everything for you. And with Gateway Load Balancer and a bunch of VM series firewalls behind it, and you just get an endpoint that you can start routing traffic to. So it's a lot of work with AWS, and we'll continue to do that with AWS. But so it just shows that how you do that. Most of the customers will use Terraform templates or Ansible playbooks to just come up with a blueprint of, as they deploy VPCs or accounts that they are giving to their internal customers, firewalls are just baked into it. Either a distributed deployment where two firewalls or few firewalls are baked into every VPC, so they see all the traffic going in and out of those VPCs, or a centralized deployment where they hook a security VPC to the transit gateway and then just have all the traffic flow through that. But it's all automated. Nobody's doing this manually. So we've done all these integrations. What it provides you is these three use cases. These are the three main use cases the customers using VM series firewalls for. The biggest one is the outbound egress filtering, because most of your workloads require outbound connectivity to internet for some reason or the other. And once you open your security groups, then it's they can connect to whatever they want. They want to connect to just some APIs, Facebook, Google, whatever. But once you open that HTTP 443 port, then who knows what they're connecting to. So that one is the big use case, because once these workloads are compromised, they would connect to command and control centers and turn into bots, crypto mining, all sorts of bad things happen. So customers make sure that anything that is going outbound is going through the firewall, and they go either with pure whitelisting model where they only allow the APIs that are needed by those workloads, or they and then block everything else. That way you're completely protected. But of course then you have to make sure that every API that the developer needs to be whitelisted in the policy. The other approach that some of the customers take is they allow everything, but they use our URL filtering categories to block bad stuff. So no connections to command and control centers, no connection to gambling sites, things like that. You can just block bad categories and allow all the good stuff out. So that's an easier way of doing it. I mean, our customers do it both ways. So that's the first use case, and I'll talk about a customer case study that highlights that. The second one is inbound use case, where these applications are being exposed either to the general user population or to your partners, sometimes your internal users, and they want to make sure that only good connections are coming into the applications, and someone is not trying to exploit vulnerabilities that you have and break into your infrastructure. So that's the second one. The third one is the east-west, which is getting more and more popular. VPC to VPC traffic, taking that through the firewalls, and this is really driven by zero trust. As you grow your cloud usage and you have thousands of applications running with different risk profiles, people want to make sure that traffic that's crossing these VPC boundaries is also going through the firewall, because you can't make sure that all of this stuff is secure. And as I said before, the attackers need just, you need to be right 100% of the times, and they need to be right only once. So once they break in, you want to make sure that you have enough layers protecting everything. So VPCs tend to be the trust boundaries in AWS, and that's where the firewalls are generally deployed. We are starting to see some customers starting to push that boundary even within VPC to subnets or other things, but generally, VPCs being the boundary where the firewalls are deployed. So just wanted to share real customer example. This is a leading online travel company. And the way they have done this in AWS, they have thousands of VPCs, lots and lots of applications running, exposed to the internet. The way they did this, the use case, their primary use case was outbound connectivity. They, had to comply with, different, compliance requirements, their internal compliance as well. So what they did is they automated VM series. So VM series firewalls are deployed in every VPC. As they launch new VPCs, the firewalls are just baked in, and every VPC, based on their outbound connectivity requirement, gets a pure whitelist list of URLs that are allowed outbound through those firewalls, and it's all specified in the application team's YAML files. So the application teams would say, I need access to these 7 APIs. And as they launch stuff, those YAML files are read and they're fed into the firewalls. The firewall will only allow those outbound connections and nothing else. And that way, everything is locked down. As they scale things up, deploy more and more VPCs, as the firewalls are just baked in, they just keep replicating this. They're using VPC tags, EC2 instance tags to tie those with the policy. Our Panorama actually reads those tags and turns those into IP addresses for the firewalls in real time. So you don't have to worry about IP addresses, subnets. You can just use these AWS tags and metadata to do that. So that's what they've done. Just wanted to share that. Another thing that we did recently is it's really hard to quantify the value of security. How much money do you put on a avoided breach that could destroy your brand or result in loss of customer data? So we hired Forrester to do this study with our customers and build a financial model. We also wanted to quantify the value of all the automation and integration that we have done with AWS and how much money and dollars does it save for you. So the study was really interesting. We came out in flying colors. I would encourage you to download that study. Results in 90% reduction in time required to deploy firewalls, and some of this comes from our integration with gateway load balancer and other technologies that AWS has built. And also, we try to put some numbers on what is the cost of the preventing the security breaches. So those are some of the numbers. It also has a financial model built into it, so you can adjust if you need to make a business case within your company. Okay, wanted to switch gears to CN series. So CN series is something we launched last year. It's the containerized version of our next-gen firewall, so very similar to VM series, but delivered as a native Kubernetes application. Again, it's powered by the same PAN-OS, same security services, same Unit 42 threat intelligence. So something we detect on one of our hardware firewall would be programmed onto our CN series firewalls as well. So that protection goes along on all form factors. Just wanted to say that today we launched CN series Paygo on AWS Containers Marketplace Anywhere, which was launched this morning. So just wanted to highlight that. But one thing that customers always ask me, why do I need a next-gen firewall for my containerized deployment? You guys said shift security left, scan everything in dev, and John has been preaching that forever. So why do I need a next-gen firewall? Ideally, you would have scanned everything and prevented everything, from going into production and fix everything before you go into production. But reality doesn't really work like that. Sometimes these vulnerabilities are detected and the patches are not even available for weeks. Once they are available, you can't suddenly upgrade all your infrastructure to the latest version of Kubernetes. It takes you time before you can upgrade it. So there's always a time window where you're exposed to these known vulnerabilities. Sometimes, the business teams, they need to go in production and you can scream and say whatever, they end up pushing the application to the production anyway because they have their business reasons. So you end up with these vulnerabilities. And containers are no different from VMs. They're running the same application. So MySQL, Redis, Jira, whatever you're running, it's just a new form factor. So all the network-based attacks, that the VM-based applications are prone to, containers are too. Of course, as John said, you have the opportunity to address those things earlier, so it improves the situation. But if you're living with these vulnerabilities, then you still have the same cryptojacking problem and ransomware problem and botnet problem. And we've seen that in 2019. There was a worm called Graboid that infected 2,000 unsecured Docker hosts, and people were mining cryptocurrency on them. So it's not like these things are unheard of. They're there for containers as well. So as these container deployments grow, the same thing happens that happens in cloud. Customers end up with these large Kubernetes clusters that are running many different applications, and their risk profiles are different. Some applications need PCI compliance, other are non-PCI. Some applications are really clean, cloud native, completely scanned and no vulnerabilities. Others are lift and shift, running Java, some legacy code. So you end up with a mix, and you really, at that point, your trust boundary shifts to like Kubernetes namespaces, and that becomes the trust boundary. So people start looking for layer 7 level visibility and control within this big Kubernetes cluster, because otherwise it just becomes a big black hole. People are looking for, something that you can deploy as a new native Kubernetes, application. So that's what CN series does. You can deploy it, using the standard Kubernetes YAML files, Helm charts that we have built. It's really the same firewall. It can run as a daemon set on every node, or you can run it as a shared Kubernetes service on a cluster. Once you deploy it, which is really easy, all you have to do is put a few annotations in your application YAML files, and we then hook into the CNI infrastructure to start routing all the traffic, in and out traffic from that namespace or from that pod through the firewall, and now you have full layer 7 visibility and control. It also uses Panorama. So again, the consistent policies that you were using on VM series or hardware firewalls, you can directly apply all of that to your CN series firewalls now. Panorama also has a plugin for Kubernetes, just like it does for AWS, where we farm out all the pod labels, annotations, namespaces, so you can directly use them in your policy. You could say that this namespace, I want to allow these outbound connections, and we'll apply that to just that namespace. So that's what CN series does. We had the BYOL version, before, and today we added the PAYGO version in AWS, which is really nifty because this new marketplace for containers anywhere actually allows you to buy CN series, as a PAYGO thing in AWS, but it also allows you to deploy it on-prem. Because a lot of customers are using containers on-prem in their data centers. So that's really, really cool because it allows you to retire your EDP. It allows you to quickly just buy it from Marketplace as a PAYGO thing, and you can use it anywhere. So that's something really cool. You should check it out. All right, so the use cases for CNC is kind of similar. As I talked about, these big Kubernetes clusters, what happens is, first of all, you end up with PCI, non-PCI, cloud native and not so cloud native applications running. The second thing that comes up quite often, when I talk to customers is one of these applications suddenly requires connectivity to some backend critical database. And that outbound connection, because when it comes out of Kubernetes, gets netted. If you have anything outside this cluster, you end up opening that backend connectivity to the entire cluster. And that drastically increases your attack surface. The same thing could happen if one little application needs outbound connectivity to the internet. You end up opening the outbound connectivity to pretty much everything, the whole cluster. So CN-Series helps with that. You can stop data exfiltration. You can stop command and control connections that are going outbound. So it scans the traffic so that you can not only allow and deny connections based on like full API or URL level, because we have that layer level control, but it also scans the traffic over those connections to make sure that it's all valid application traffic, not C2 traffic or data exfiltration attempts. The second one is the inbound, very similar. Some of these applications need to be exposed to external users on internet or partners or internal users. So you use CN-Series to allow those connections in and make sure that they are not breaking attempts, and it's regular connections. And the third one I already talked about is the east-west, PCI, non-PCI, just segmenting that and having full visibility into what's going on within the cluster. And as I said before, once your clusters grow, namespace tends to become the trust boundary. Zero Trust is also pushing these trust boundaries, closer and closer to the workloads. So once namespaces become the trust boundary, you really need a firewall inside the Kubernetes cluster to really have that visibility and control. Another customer example, online retail company. They've gone with this large Kubernetes cluster. It's running hundreds of different applications, and they auto scale, because their business is seasonal, and some of these applications deal with payments data, so they had to be PCI compliant. And before they talked to us, they were literally being forced into forking these Kubernetes cluster into two. So they'll have a PCI cluster and a non-PCI cluster. And they were afraid that every time they need to now launch a new application, first they have to decide whether it goes on the PCI cluster or the non-PCI cluster. That increases their operational overhead. And then sometimes the application is non-PCI, so it goes on that cluster, and then 3 months later, now it needs access to the payments database, and now it needs to be moved to the PCI cluster. So they're worried about all this. They really wanted to keep the same cluster and be PCI compliant on that cluster. They also wanted whatever security solution they choose, they wanted it to be really native to Kubernetes because they've gone completely container native. And security had to scale with the applications. As the seasonality kicks in, these applications start sending a lot of traffic, security had to scale along with that as well. So CN-Series was a good fit. They deployed the CN-Series on those clusters, and they're using all three use cases, the east-west to do the PCI segmentation, the outbound connections, they're controlling it per namespace, which namespace is allowed to connect out to internet or other internal services, and inbound as well, where they have like users connecting to these applications. So really good, useful case study. All right, so sum it up, the cloud network security really is the best-in-class security. That is really, really important because you'll see a lot of like firewalls or network security solutions that are really easy, but the security, if they're not protecting you against 95, 98% of the attacks, then being easy is not good. It needs to provide that best-in-class security. As you see advanced threats, it needs to be able to detect them and prevent them, and that's where we really shine in. So both VM-Series and CN-Series, because they're powered by the same platform, bring that best-in-class security. On top of that, we have done lots and lots of cloud integration with AWS to make it really easy to deploy, make it seamless experience. So just like you're using everything in AWS, VM-Series and CN-Series is native to Kubernetes, same thing. Lots of automation. So Terraform templates, Helm charts, we've invested a lot in developing that and support giving that, so you don't have to do all that work from scratch, and you can just take it and then modify it to your taste and deploy it. And the last one is ease of management, which Panorama plays a big role in that. because a lot of customers have the same policies, same prevention techniques that they want to apply in their data centers, in the hardware firewalls and VM series firewalls, as well as the CN series firewalls. So we have these, Panorama provides that consistent management layer. It also has these specific plugins built in for AWS, Azure, and other public clouds, Kubernetes, so you can get that metadata and use that in your policies. Okay, so that was about network communication. The last piece we wanted to cover was SOAR. So, sorry, my daughter was calling. The last piece is, you'll do all of this. You'll do your attack surface management. You'll secure your applications with Prisma Cloud. You'll secure your network. All of these things generate a lot of alerts. And most of the customers find, afterwards that they had the breach, that there were some alerts. If they looked at it in time, they might have prevented the breach. So two things there. The expense that John talked about, allows you to do that attack surface management, that external view of how your enterprise looks to the attacker. But the other product in Cortex family is XOR, which came out of our Demisto acquisition. What that does, it stands for Security Orchestration Automated Response. It literally turns all the manual work that a SOC analyst would do into a playbook. And it's UI driven, it's very easy to use. So we have hundreds of playbooks available in our XOR platform, and we've also opened a marketplace where we have 800 plus third-party playbooks available now. So common tasks that everybody is doing, it just kind of automates that. You can use it for lots and lots of cool things. Some of the examples, if you find a vulnerability, you can use XOR to take that and program the firewall so you can block those ports or isolate those affected hosts. So all of this work in XOR can be done really, really easily, really effectively. So automation saves a lot of time. Other examples of Prisma Cloud detect some shadow assets that you were not aware of, and you can use XOR playbooks to automate that and put that under your management or governance. If you can't do that, you can put it for some compliance review. So these are some examples of how you take all these alerts or things and program these playbooks to complete that feedback cycle. So if you look at all four things together, you're detecting your attack surface, you are protecting your applications, you're protecting your network, and then whatever alerts are coming, you're remediating those using those controls, using these automated playbooks. So that just kind of completes the full cycle. Those were the things we have. So just to kind of sum it up, you really need to look at cloud security holistically. All four things will give you that complete loop of, protect your applications, keep an eye on your attack surface management, and then create that feedback loop so it keeps getting better and better on all four fronts. Our strategy has been to give you the broadest, security technologies that are needed, but each one of them are best in class and they are deeply integrated. That's what, that's why I was describing that whole platform story. That has been our strategy. So if you look at Prisma Cloud, if you look at our network security platform, that's what you would see. And we are also tying Prisma, Cortex, and our network security technologies together as well, so they work better with each other. And that's kind of our strategy. That's our vision for our customers. And we continue to work with AWS on multiple fronts, not just network security, but all fronts to make things better and better in AWS. So, yep, that's what, we have a big team at booth 861. Go there, ask for a demo. We have lots and lots of cool demos. You'll open up for questions here if you have some. Thank you. Yes. Yeah.
So if my nodes are already protected by the VM series firewall, so why do you need a CN series firewall for the containers running on the same node?
Okay, so the question was, if my nodes are already protected by VM series firewall, why do I need a CN series firewall? So it really depends on what is behind that VM series firewall and where is your trust boundary. right? So if you have 10 nodes and you have a VM series firewall and you don't need visibility and control within that cluster, then you don't need it. Because the risk profile of all the applications running in that cluster is same. Now, if you had a 3,000 node Kubernetes cluster and you had gazillion things that were running, then the VM series firewall at that boundary may not be enough. Then if you need to push that boundary inside the Kubernetes cluster, that's when you'll need CN series firewall. Does that help?
Yeah.
Okay.
The second question, so this question keeps coming back.
So how does these firewalls help protecting TLS-based traffic, especially when we are not terminating TLS traffic on the firewalls?
Yeah, so we do support TLS decryption on the firewalls. So first of all, if you wanted to decrypt all that traffic, we can, and a lot of customers do that because TLS hides a lot of these attacks these days. Second is, even without TLS decryption, we do look at a whole bunch of other things outside the payload, like the URLs, the other information that is available. That also gives us clues, so you can at least get that protection. Like if it's connecting to a command and control center IP address or a URL that we're already aware of, we'll block that. But for the full inspection of that traffic, you need the TLS decryption, which we do support.
So we have a global transit gateway environment. We've moved everything to AWS, closed, shut down our data centers. Luckily, as soon as you started supporting the gateway load balancers, the magic of how we were going to do inspection VPCs,
Yep.
which are attached to every transit in every region around the globe, it's been working great. But there are features that we kind of need. Your incorporation of the gateway load balancer was great for the transit gateway, but there are times you want to have an endpoint and an endpoint service that don't go through the transit. Doesn't work. We waited for a couple patches. The patches didn't fix it. What's the best way for us to be engaged? Whether it's either hiring Palo resources, which would be fine. Like there's a couple features it'd be like a home run for us if we could get, and we just want to get the right path into Palo to it.
So after we're done here, let's talk. I can help with
Thank
that. Yeah.
Any other questions?
Can you speak a little bit to, you mentioned the CN series firewalls, but within Prisma Cloud Compute, there's also the network security module, which has the CNNF, I think is what it used to be called, and
Right.
those features. Are you guys starting to differentiate? Is that going to be a migration path? What's the plan?
Yeah, I mean, I think they solve different things. CNNF is basically like a host-based way to secure traffic between entities, like let's say an entity-based, not even a firewall, just a very straightforward and basic way to say this entity should be able to talk to that entity or not. CN Series obviously provides a much more in-depth set of capabilities, a full-blown next-gen firewall. And it really just kind of depends on what you're looking for. Like Mukesh said, like if your needs are very basic, you just want to allow one thing to talk to another, perhaps CNNF would be sufficient. If your needs are more sophisticated, you need to be able to actually inspect traffic and have all the threat protection and so forth, CN Series would be a better fit for you for that. Okay, well, thank you guys very much for your time.
Thank you.
Thanks for coming.
Thank you so much.